Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5. So today we would like to present Module 11, Polymer Production of Hdpe and Lldpe. The group consists of 3 members, which is me, Muhammad Nazmi Mehmet Fauzi, Syairah binti Muhammad Yusuf, and the last one is Izzah Khairina binti Malik. So, I will explain in more detail about production of Hdpe and Lldpe. Ldpe is very versatile polymer. At the present, the technology for e-production is not the first choice for new plant due to very high investment and operation costs. Then, low pressure processes for the productions of linear low density polyethylene Lldpe has been introduced, which can be used in many of traditional Ldpe outlets. Hdpe can also be produced in low pressure plant, making them more flexible than high pressure plant. Many of the common catalyst polymerization processes are suitable to produce both Hdpe and Lldpe. Some processes include, the first one is bulk polymerization, which polymer dissolve in monomer. Second, solution polymerization, which polymer and monomer dissolve in hydrocarbon solvent. Third, slurry polymerization, which catalyst polymer particle suspended in hydrocarbon diluent. The last one is fluidized bed polymerization, which catalyst polymer particle fluidized in gaseous monomer. Lldpe can also be produced in high pressure processes in the presence of Ziegler-Natta type catalyst and with the right comonomer. Although this route is not seen as suitable for a new investment, several manufacturers has modified existing Ldpe plant for the productions of Lldpe. This section focuses on the fluidized bed polymerization process, also referred to as gas phase polymerization. This is the most flexible process because it is capable for producing both Hdpe and Lldpe and can use a wide range of solid and supported catalysts. It also is the most economic process because it does not require a diluent or solvent and hence no equipment or energy for their recovery and recycle.
Next, for the fluidized bed polymerization process, in figure 11.13 shows a flow scheme of a fluidized bed process. A wide variety of heterogeneous catalysts can be used, ethene, hydrogen, and comonomer for the production of Lldpe, mainly 1-butene and 1-hexene, are fed to the reactor through a grid which provide an even distribution of the gas. The recirculating ethene gas fluidizes the catalyst in the shape of spherical particle of about 50 micrometer, on which the polymer grow and enable efficient mass and heat transfer. The characteristic shape of the reactor about 25 meter height, length to diameter ratio about 7, with a cylindrical reaction section and a large diameter section where the gas velocity is reduced, allow entering particle to fall back into the bag. Remaining polymer particles are separated from gaseous monomer in a cyclone and returned to the reactor. Is the resident time of the PE catalyst particle in the reactor range from 3 to 5 hours, during which they reach an average size about 500 micrometer. The powder is taken off at regular interval near the bottom of the reactor trough. The polymer contains an appreciable amount of ethane, which is mostly separated in the cyclone operating at near atmospheric pressure and recycled to the reactor. The remaining ethane is purged from the polymer with nitrogen and stored. Because of the high activity of current polymerization catalyst, over 1,500 kg of polymer is produced per gram of metal, depending on catalyst. Therefore, the catalyst remain in the product of no residual catalyst removal unit is required. Although this impurity level is low, it still limit to the number of application of the production, and there is an incentive to develop system with higher turnover. A catalyst has been developed then can yield 6,000 kg per gram metal. Temperature control it's very important to keep the polymer particle below their melting point, 390 K and 3 Kelvin and 373 Kelvin for HDPE and LLDPE respectively. And to prevent a thermal runaway reaction, when using cooling water from a cooling tower, the available temperature difference from cooling the gas should be at least 40 to 50 Kelvin. From this value, it can be calculated that the single pass conversion of ethane is limited to about 2%, somewhat higher if higher alkene comonomer are used as in LLDPE production. That's all.
Economy of polyethylene production process. Table 11.5 compare the cost for some LDPE, HDPE, and LLDPE processes. Scale listed is based on the largest stream size available for lysine. The monomer and comonomer cost contribute most to the total cost 70%. LDPE process are not competitive with LLDPE process due to the large investment cost involved. For LLDPE production, important of the capital cost factor is the difference between the solution process and the fluidized bed process. Even at much lower capacity, the capital costs are much higher for the solution process. However, the costs for the solution process are based on the DuPont process. The comparison might be unfair regarding the solution process. For HDPE production, the data for the Ziegler process are based on the early process, which include facility for the removal catalyst. Since it has been possible to eliminate this step, which lead to the lower cost production. Next is top polyethylene company. First company is ExxonMobil. ExxonMobil, one of the world's largest publicly traded energy providers and chemical manufacturer, develop and apply next generation technology to help safely and responsibly meet the world growing needs for energy and high quality chemical products. Second is Lldpe Chemical Company. Lldpe Chemical Titan production site in Malaysia consists of 12 plants, 2 cogeneration plants and 3 tank farms. They are located on 2 sites, in Pasir Gudang and Tanjung Lasat in the state of Johor. Last company is GTMax. GTMax Plastic Industry Sdn Bhd is a rapidly emerging market player in the plastic film extrusion industry, producing a wide range of plastic products such as LDPE, LLDPE, HDPE, and host of other plastic film related products. So that's all from us. Thank you.